You see something moving through space at 245,000 kilometers per hour, faster than any object we have ever tracked, 20 kilometers wide, coming from outside our solar system, and it is heading straight for the inner planets. July 1st, 2025, Chilean Observatory, Atlas Telescope. A dot of light appears where no dot should be. Within 24 hours, astronomers know they are looking at something that does not belong here. 3I Atlas, the third confirmed visitor from interstellar space, but this one is different, bigger, faster, stranger. And Harvard astrophysicist Avi Loeb thinks it might not be natural at all. 3I Atlas travels along the ecliptic plane. The same orbital path as Earth, the chances of that happening randomly, 2 parts in 1,000. It will pass within striking distance of Venus, Mars, and Jupiter. The probability of that trajectory, less than 5 parts in 10,000. When it reaches its closest point to the Sun in October, it disappears behind our star, hidden from every telescope on Earth. At the exact moment when a spacecraft could fire its engines to change course toward us. If you value documented space science and astronomy like this, subscribe. It is the best way to support our work. Also comment from which city you are hearing this from. This script is researched and factual, using sources from NASA's James Webb Space Telescope observations, published in August 2025, and Dr. Martin Cordner's peer-reviewed spectroscopic analysis from the Goddard Space Flight Center. Now back to the information. The James Webb Space Telescope trained its infrared eye on 3I Atlas on August 6, 2025. What it found breaks every rule we know about comets. The comet's atmosphere contains 8 times more carbon dioxide than water, 8-to-1 ratio, the highest ever recorded. 6 standard deviations above normal. In comet chemistry, that should not exist. Water ice dominates every comet we have studied. Not this one. Spherex Space Observatory confirms the findings. A carbon dioxide cloud stretching 348,000 kilometers across space. No comparable water signature detected. The comet releases 129 kilograms of carbon dioxide every second, only 6.6 kilograms of water. Something is wrong with this picture. Hubble Space. Telescope images from July 21st show a fuzzy coma surrounding the nucleus. Classic comet behavior. But the size estimates keep changing. First report said 20 kilometers diameter. Then Hubble data suggests 3.5 kilometers maximum. The difference matters. A 20-kilometer interstellar rock should be impossibly rare. We should have found 1 million smaller objects before discovering something this massive. The TESS Space Telescope found something else. Pre-discovery images from May 25th, 2025. 2 months before official detection, 3I Atlas was already active at 6 astronomical units from the Sun, past Jupiter's orbit. Most comets stay dormant until they get much closer. This one started out gassing in the outer solar system, like it knew exactly where it was going. Dr. Avi Loeb publishes his analysis July 16th, 2025. Co-authored with Adam Hibbard and Adam Crowell from the Initiative for Interstellar Studies, their paper asks a simple question. What if 3I Atlas is not natural? What if it is a probe from another star system? Loeb invokes the dark forest hypothesis, the idea that alien civilizations stay hidden because the universe is full of predators. Any species that reveals itself gets destroyed. But reconnaissance missions still need to be sent to map potential targets, to gather intelligence. The trajectory fits perfectly. 3I Atlas approaches from behind the Sun, relative to Earth's position in January 2025. It passes close enough to 3 major planets to study their gravitational fields. Its path takes it behind the Sun during perihelion, the optimal hiding spot for a spacecraft to change course without detection. If it fires engines on October 31st for 2025, while blocked from our view, it could reach Earth by late November or early December. The scientific community pushes back hard. Chris Lintott from Oxford University calls the alien hypothesis nonsense on stilts, an insult to real research. Steve Desch grades Loeb's statistical analysis like undergraduate homework. Tom Statler from NASA states the obvious: it looks like a comet. It does comet things. It very strongly resembles comets we already know, but the anomalies pile up. The Very Large Telescope detects cyanide and nickel in the coma on August 21st. Swift Observatory finds tentative evidence of water vapor and hydroxyl radicals. The carbon dioxide to water ratio remains stubbornly high. No comet in our solar system behaves this way, not even close. Loeb creates his own measurement system, the Loeb scale. 0 means definitely natural, 10 means definitely artificial. He gives 3I Atlas a 6 out of 10. 60% chance of alien technology. Critics point out that scaring the public with unfounded speculation crosses ethical lines. One reader emails Loeb about stockpiling food supplies and spending final moments with family before the alien encounter. The Dark Forest scenario plays out like this. An advanced civilization sends automated probes to map stellar neighborhoods. The probes disguise themselves as natural objects, comets, asteroids, space debris. They gather intelligence on potentially habitable worlds, study planetary defenses, map resource distribution. If a target species shows signs of rapid technological development, the probe reports back, elimination protocols activate, strike first before the threat grows stronger. 3i Atlas fits the profile. It arrives during humanity's most rapid space expansion phase. Private companies launching thousands of satellites, Mars exploration missions preparing for launch, asteroid mining ventures getting funded, nuclear propulsion systems under development. From an outside perspective, we might look like a species about to become dangerous. The comet will make its closest approach to the Sun on October 31st, 2025, Halloween. For approximately 2 weeks, it disappears behind the solar disk. No telescope on Earth can track its position or movements. If it is artificial intelligence, this represents the perfect window for undetected maneuvering. A reverse solar Oberth maneuver, using the Sun's gravity to brake and change trajectory without burning excess fuel. NASA's response comes in September 2025. Tom Statler, lead scientist for Solar System Small Bodies, addresses the speculation directly. The evidence overwhelmingly points to a natural comet. It behaves like a comet should behave. The unusual chemistry simply reflects different formation conditions in its origin star system. High carbon dioxide content suggests formation beyond the carbon dioxide frost line in an alien protoplanetary disk. Radiation exposure during millions of years in interstellar space altered its ice composition. The James Webb observations reveal another clue. Heavy carbon dioxide containing carbon-13 isotopes, the same isotopic ratio found on Earth. This suggests the comet formed in an environment with similar carbon chemistry to our own solar system. Natural processes, not artificial engineering. The presence of carbonyl sulfide, water ice, and carbon monoxide also matches expectations for long-period comets, just with unusual ratios. Daryl Selliman leads the first peer-reviewed study on 3i Atlas. His team reports classical signatures of cometary activity. Outgassing patterns match theoretical models. Dust production rates follow predicted curves. The reddish color in its coma comes from organic compounds sublimating in sunlight. Everything points to natural origin. Seligman states there have been numerous telescopic observations demonstrating standard comet behavior. The Galileo project continues monitoring. Avi Loeb's research initiative operates 3 observatories in Massachusetts, Pennsylvania, and Nevada. They plan intensive observations during the October perihelion passage, looking for any signs of artificial maneuvering. Spectral signatures of propulsion systems, course corrections that violate gravitational predictions. The data will either confirm natural comet behavior or reveal something unprecedented. Multiple space agencies coordinate tracking efforts. European Space Operations Center provides orbital mechanics support. Japan's Hayabusa missions offer comparative data from other small bodies. China's Deep Space Network adds redundant tracking capability. If 3i Atlas attempts any course changes, the global astronomy community will detect them within hours. The Amateur Astronomy Network mobilizes as well. Backyard telescopes across 6 continents take regular position measurements, crowdsourced observations, create real-time tracking bulletins. Any deviation from predicted trajectory gets reported immediately through online forums and alert systems. The distributed monitoring makes covert maneuvering practically impossible. Critics note fundamental flaws in the alien probe theory. Interstellar space contains insufficient rocky material to naturally deliver 20-kilometer objects into inner solar systems. The numbers do not work. We should have detected thousands of smaller interstellar visitors before finding something this large. Unless it targeted our solar system deliberately, which brings us back to the artificial intelligence hypothesis, a probe designed to study specific star systems rather than drift randomly through space. The orbital dynamics also present problems for natural explanations. 3. iAtlas approaches the solar system at nearly the perfect angle for planetary reconnaissance. Its trajectory allows close passes of multiple worlds without requiring course corrections. A natural comet from interstellar space should follow a more random path. The ecliptic plane alignment suggests either incredible luck or deliberate navigation. Size estimates continue fluctuating based on new observations. The nucleus could be anywhere from 320 meters to 5.6 kilometers diameter. The uncertainty comes from separating the solid core from the surrounding gas and dust cloud. Larger size favors the artificial hypothesis. Smaller size fits natural comet models. The James Webb infrared data suggests most of the apparent brightness comes from the coma, not the nucleus itself. Water production rates remain puzzling. Early Swift observatory measurements suggested 40 kilograms per second at 3.5 astronomical units from the Sun. Later analysis shows much lower rates, 6.6 kilograms per second according to James Webb data. Either the comet's water content is genuinely depleted, or heat penetration into the nucleus follows unusual patterns. Both scenarios raise questions about formation conditions. The carbon monoxide to water ratio provides another data point, 1.4 to 1. More typical for known comets than the extreme carbon dioxide values. If 3I Atlas were purely artificial, we might expect all chemistry ratios to be anomalous. The mixed signals complicate both natural and technological explanations. Real comets can have unusual compositions. Artificial probes might mimic natural chemistry patterns for camouflage. Spectroscopic analysis reveals trace amounts of other compounds, carbonyl sulfide, organic molecules, dust grains smaller than 1 micrometer. The complexity suggests either natural comet chemistry or sophisticated biochemical engineering. An artificial probe designed for long-term space travel might incorporate organic compounds for radiation shielding or self-repair mechanisms. The detection of these materials does not resolve the debate. Professional astronomers express frustration with the media coverage. Legitimate scientific discoveries get overshadowed by sensationalized speculation about alien visitors. The unusual properties of 3I Atlas deserve serious study regardless of origin theories. Understanding interstellar comet chemistry helps refine models of planetary formation in distant star systems. The carbon dioxide dominance might be common among objects that formed beyond frost lines in low-mass stellar systems. Ground-based observations continue through September 2025. The Las Cumbres Observatory Network provides continuous monitoring across multiple sites. The comet grows brighter as it approaches the Sun. More detailed spectroscopy becomes possible. Each new measurement either supports the natural comet model or reveals additional anomalies that require explanation. The Europa Clipper mission, scheduled to launch in 2024 carries instruments capable of detailed compositional analysis. If 3I Atlas passes near Jupiter during its outbound trajectory, the spacecraft might obtain unprecedented close-range data. Similar opportunities exist for Mars orbiters during the comet's planetary encounters in late 2025. International Space Station crews prepare photographic equipment for potential observations. The comet's brightness and trajectory might make it visible to naked-eye observers in November and December 2025. Citizen science projects coordinate observation campaigns across global astronomy clubs. The distributed data collection effort ensures comprehensive coverage regardless of individual telescope limitations. The Vera Rubin Observatory in Chile begins operations in 2026. Its wide-field survey capabilities should detect dozens of additional interstellar objects over the next decade. Statistical analysis of a larger sample will determine whether 3I Atlas represents a genuine anomaly or falls within normal variation for interstellar visitors. The Rubin data might settle the debate through sheer numbers. Military space surveillance networks maintain classified monitoring of 3I Atlas throughout its solar system passage, while official statements emphasize scientific cooperation. National security agencies track any object that approaches Earth's orbital vicinity. The Space Force's tracking capabilities exceed civilian astronomy resources in some wavelength ranges. Classified data might reveal details not available through public observations. Commercial satellite operators also monitor the comet's progress. SpaceX's Starlink constellation provides distributed observation platforms across multiple orbital planes. Planet Labs, imaging satellites, capture daily photographs of the comet's changing appearance. Private space companies have financial interests in understanding potential collision risks from interstellar objects. The insurance industry begins calculating risk premiums for extraterrestrial encounter scenarios. Lloyd's of London develops preliminary coverage frameworks for alien contact events. Actuarial analysis treats the 3I Atlas situation as a test case for quantifying unknown risks. The economic implications of genuine alien contact would reshape global financial markets within hours. Academic institutions establish rapid response protocols for handling potential evidence of extraterrestrial intelligence. Harvard's Galileo project serves as a coordination hub for multi-institutional analysis efforts. MIT's Kavli Institute provides computational resources for trajectory modeling. The University of California system coordinates West Coast observation networks. Preparedness planning occurs regardless of probability assessments. Religious organizations also prepare theological frameworks for potential alien contact scenarios. The Vatican's Pontifical Academy of Sciences issues statements supporting scientific investigation of unusual phenomena. Islamic astronomy centers coordinate observation efforts across Middle Eastern countries. Buddhist temples in Asia incorporate interstellar visitor monitoring into traditional sky watching practices. The psychological impact on public consciousness proves significant. Social media platforms see increased discussion of space threats and alien contact scenarios. Science fiction book sales spike following news coverage of 3I Atlas theories. Hollywood studios fast-track alien invasion movie projects. The cultural response demonstrates humanity's deep-seated anxieties about our place in the cosmic hierarchy. Educational institutions adapt curricula to address student questions about interstellar visitors and alien intelligence possibilities. Elementary schools incorporate basic astronomy lessons about comet behavior and space object detection. High schools add units on astrobiology and the search for extraterrestrial life. Universities expand enrollment in planetary science and astrobiology programs. The search for extraterrestrial intelligence community experiences renewed funding interest. SETI projects receive increased donations from private individuals concerned about potential alien presence. Radio telescope arrays expand listening capabilities to monitor 3I Atlas for artificial signals. The possibility of active alien reconnaissance validates decades of SETI research priorities. October 31st, 2025 arrives. 3I Atlas reaches perihelion. Hidden behind the sun from Earth's perspective, every major observatory on the planet waits for the comet to emerge from solar occultation. The 2-week window represents humanity's first real test of interstellar object monitoring capabilities. Either the comet follows predicted gravitational trajectories, or it reveals artificial maneuvering systems. December brings the answer. 3I Atlas reappears on schedule. Its trajectory matches computer predictions within measurement error margins. No course corrections detected. No artificial signals recorded. The comet continues its hyperbolic path out of the solar system, carrying its unusual chemistry back to interstellar space. Natural forces govern its motion through the inner planets, but questions remain. The carbon dioxide to water ratio defies conventional comet formation models. The timing of its approach during humanity's rapid space development phase seems suspiciously convenient. The perfect ecliptic plane alignment enables comprehensive planetary reconnaissance. These anomalies might result from natural processes we do not yet understand, or they might indicate something more deliberate. The scientific consensus settles on natural origin with unusual formation conditions. 3I Atlas formed in an environment rich in carbon dioxide ice, possibly around a low-mass star system where the carbon dioxide frost line extended further from the stellar core. Millions of years in interstellar space exposed its surface to cosmic radiation that altered ice composition ratios. The unusual chemistry reflects exotic birthplace conditions, not artificial engineering. Avi Loeb maintains the technological possibility deserves continued consideration. The Galileo project establishes permanent monitoring protocols for future interstellar visitors. Early detection networks expand coverage to identify incoming objects months or years before closest approach. The 3I Atlas experience demonstrates the need for rapid response observation capabilities and international coordination frameworks. The most unsettling revelation emerges from deep analysis of the discovery timeline. 3I Atlas was photographed by multiple survey telescopes weeks before official detection. The object moved through dense star fields near the galactic center, where automated detection algorithms struggled to identify it against background sources. How many other interstellar visitors have passed through our solar system undetected? How many reconnaissance missions have we missed? Amateur astronomer Sam Dean finds Atlas telescope images showing 3I Atlas as early as June 5, 2025, nearly a month before official discovery. The object was there, photographed, archived, ignored. Only after its July 1st confirmation did astronomers search backwards through existing data. The delayed recognition suggests our detection methods may be inadequate for comprehensive interstellar object monitoring. Pre-discovery observations from the Zwicky Transient Facility stretch back to May 21st, 2025. More than 6 weeks of unrecognized data. 3I Atlas traveled through the inner solar system for months before human intelligence recognized its significance. An artificial probe could complete extensive reconnaissance operations during such detection gaps. The possibility that we are being surveyed without our knowledge becomes genuinely plausible. TESS telescope data shows cometary activity beginning at 6 astronomical units distance, far beyond the normal activation threshold for water ice sublimation. If 3I Atlas is artificial, its designers would need to mimic natural outgassing patterns to avoid detection. The early activity could result from sophisticated camouflage systems, or genuine comet behavior in unusual ice compositions. Both explanations remain scientifically viable. The ultimate test may come from chemical isotope analysis. Natural comet formation should produce specific isotopic signatures that reflect stellar nucleosynthesis processes in the birth system. Artificial construction would likely show different isotope ratios, indicating manufactured rather than accreted materials. The James Webb Space Telescope detected carbon-13 isotopes, but more detailed analysis may reveal subtle artificial patterns. Future missions to intercept interstellar objects become a strategic priority. The European Space Agency studies rapid deployment probe concepts for 3 I-Atlas-class targets. NASA evaluates solar sail interceptors that could reach interstellar visitors within months of detection. China develops nuclear thermal propulsion systems for deep space reconnaissance missions. The recognition that interstellar objects may carry intelligence transforms space exploration priorities. In the end, 3 I-Atlas leaves us with more questions than answers. The fastest, largest, chemically strangest interstellar visitor we have ever studied. It approached our solar system along the perfect trajectory for planetary reconnaissance. It hid behind the sun at the optimal moment for course changes. It displayed chemistry unlike any natural comet in our experience, and it departed as mysteriously as it arrived, carrying its secrets back to the stars. Whether natural phenomenon or artificial intelligence, 3 I-Atlas demonstrates how little we understand about our cosmic neighborhood. The universe may be far more active and far more dangerous than we ever imagined. Next time, we might not get so lucky.